Okay, so members, now we are going to see how do we determine the equation of a tangent and the equation of the normal to a rectangular hyperbola. But please don't forget to subscribe to the channel. Now, the tangent, of course, meets a curve at one point, and now at that point, a normal is perpendicular to that tangent. And at that point still, the gradient of that curve is the same as the gradient of the tangent. So this is our point of intersection between the tangent and the curve, say point C. The gradient of this curve and the gradient of this tangent is the same. So we are going to see examples. Find the equations of a tangent and a normal for the rectangular hyperbola at the point this. Now we say to get the gradient, either differentiate the parametric points or first form the curve itself, then you differentiate that curve at a given point. Let us see. Now from here they are giving me the value of x as and y. Now here I need to make the curve, so I remove this parameter t. So that from here will be t, and from here, so that t and t are the same, so, and you see from there, my xy will be t squared. So this is the curve, this is our rectangular hyperbola. Now we need to differentiate to get the gradient. So, you see that this is the product rule. We say fix x, differentiate y, get y, x, then plus fix y. When you differentiate x, you get a 1 equaling to a 0 differentiate, because that's a constant. Taking the other side, so now my dy, the x will be, now this is negative y divided through by x. By now, I have these points already. So my x is this is my y. So then I put my y, the x when x is ct, and my y is c over t is going to be, I have negative, this negative, c over t, then ct, the x. And so that now, from there, what we shall get is negative 1 over, so that this is going to cancel that, then this will be t squared. So that's the gradient of the tangent and the gradient of the curve at this point. So because our tangent is a line, we always use this formula to get any equation of a line where our line is passing through this point, x, y, with those two coordinates, x1 and y1. So we have its tangent, we need now a point where it passes. Because it's a tangent at this point, it means at this point t, c over t, this is x1, this is y1. So from there, just substitute. Now my y, the equation of a tangent is going to be now y minus equaling to, now the gradient into x minus ct. From there, members, I can cross multiply, this appears in yt squared. This time this will cancel and give me 1t equaling to negative x plus, now ct. When I take this beside, so that now my yt squared will be negative x, then plus, this will give me 2ct as the gradient of my tangent, as the equation of the tangent. When I come down to the equation of the normal, remember the gradient, we say the normal, they are perpendicular at this point. So m1, m2 is negative 1, but m1 is already here for the tangent. So I have negative 1 over t squared, m2 equal to negative 1. From here, my m2 is t squared. Still, if I use this formula, because a tangent and a normal are that same point. I mean, that is it's going to be also its point. So y and then c over t equal to t squared into x minus ct. So it's that this one will be now y equaling to t squared x then minus ct cubed, and then bring this side, it comes down plus c over t. You can choose to multiply through by this t, or you can leave it there. So members, that's how we get a gradient of a normal, I mean the equation of a normal and of a tangent to a rectangular hyperbola. Don't forget to subscribe to this channel. I wish you my best.